In this problem, I'm going to show you how to calculate the average atomic mass of chromium. As you saw before, there's a few steps here. Step one is to take the numbers out of percent. So if we take a look at this first one here, it's 4.310%. And if you remember, to take something out of percent, you move the decimal over to the left twice. So this will become 0.04310. So we're going to do that for all four of them. Okay, now that we took them all out of percent, the second step is you multiply each of them by their atomic mass unit. And these numbers were from up here. Okay, so we get these numbers from the calculator. Then we're going to round them because here we're multiplying. And so you go with the least number of sig figs. So for this one, it's 1, 2, 3, 4, 5. This also has 5. So we're going to round this first one to 5 sig figs. Most of these are going to have 5. The last one's going to have only 4 because this only has 4 sig figs. Now that we rounded them all to the correct number of sig figs, we're going to add them all. When you're adding, the rule with sig figs is you go to the least number of decimal places. These all have 3, so our answer is going to have 3 decimal places. And our answer when we add them up is 51.996. If you were to look on the periodic table for chromium, the number underneath it would be 51.996, or pretty close to this. So what we've done here is we've figured out that number that's on the periodic table, the average atomic mass. Now notice that it's pretty close to 52, right? So if we take a look back up here, this one was about 52. It was 51.9, which is actually pretty close to what the number is. Now, that's where this 83 becomes interesting. Notice that it's the highest percentage, which means in nature, you're more likely going to find one that's 52 or close to 52 AMU. So it makes sense that the number down here is very similar to the number that has the largest natural percent abundance. Doesn't always work, but sometimes it does.